Permit-by-Postcard program was a system implemented in some municipalities across the United States, designed to simplify the permitting process for minor electrical repairs. This system aimed to encourage homeowners and contractors to obtain permits for all electrical work, no matter how small. Under the Permit-by-Postcard program, individuals seeking to perform minor electrical repairs could obtain a permit by filling out a postcard and mailing it to the local building department. The postcard served as the application for the permit, streamlining the traditional process, which often involved lengthy forms and multiple visits to the building department. The information required in the postcard typically included details about the scope of the repair work, the location where the work was to be performed, and the name and contact information of the person or company responsible for carrying out the work. Once the building department received the completed postcard, the information was entered into a database or tracking system. This allowed the department to maintain records of all permitted electrical work within its jurisdiction. A key component of the Permit-by-Postcard program was the random selection of permits for inspection. After the postcards were entered into the database, a predetermined percentage of them would be randomly selected for inspection by a building inspector. This random selection process helped to ensure that at least some of the permitted electrical work was being checked for compliance with electrical codes and regulations. When a permit was selected for inspection, a building inspector would visit the property where the electrical work was performed to verify that the work had been done in accordance with applicable electrical codes. During the inspection, the inspector would examine the wiring, connections, and other electrical components to ensure that they met safety standards. The Permit-by-Postcard program offered several potential benefits. Firstly, it simplified the permitting process for minor electrical repairs. Secondly, it encouraged homeowners and contractors to obtain permits for all electrical work. Thirdly, the random inspection component provided a degree of oversight to ensure compliance with electrical codes. Despite its potential benefits, the Permit-by-Postcard program also faced challenges and criticisms. One of the main concerns was the lack of comprehensive oversight of the electrical work. The random inspection approach meant that a significant portion of the permitted work was not being inspected, which raised concerns about potential safety issues. Another concern was the potential for abuse of the system. Some homeowners or contractors may have been tempted to perform more extensive electrical work under the guise of minor repairs without obtaining the necessary permits or inspections. The Permit-by-Postcard program was eventually phased out in many areas due to concerns about the lack of oversight and the potential for abuse. While the program aimed to streamline the permitting process, the need for thorough inspections and enforcement of electrical codes ultimately led to the adoption of more comprehensive permitting systems. Today, most municipalities require more detailed permit applications and conduct more frequent inspections of electrical work to ensure compliance with safety standards. However, the Permit-by-Postcard program serves as an interesting example of an attempt to simplify the permitting process and encourage compliance with electrical codes. The program's focus on streamlining the process and using random inspections offers valuable lessons for modern permitting systems. Those lessons teach us about balancing efficiency and oversight. The evolution of electrical permitting systems reflects a broader trend towards increased regulation and oversight in the construction industry. As electrical systems become more complex and the potential for hazards increases, regulatory bodies have responded by implementing stricter codes and enforcement mechanisms. Modern electrical permitting systems typically involve a multi-step process that includes submitting detailed plans, obtaining permits, undergoing inspections, and receiving approval from the building department. This process helps to ensure that all electrical work meets safety standards and complies with applicable codes. While the Permit-by-Postcard program is no longer widely used, its legacy remains as a reminder of the ongoing efforts to improve the permitting process and ensure the safety of electrical systems. The program's focus on streamlining and random inspections offers insights for modern permitting systems, highlighting the need for continuous improvement and adaptation to meet the evolving needs of the construction industry. The principles behind electrical codes are based on safety and ensuring the protection of people and property from electrical hazards. Electrical codes address a wide range of issues, including wiring methods, overcurrent protection, grounding, and equipment installation. The codes are regularly updated to reflect advancements in technology and address new safety concerns. Compliance with electrical codes is essential for preventing electrical fires, shocks, and other hazards. Building inspectors play a crucial role in enforcing electrical codes and ensuring that electrical work is performed safely and correctly. Inspectors review plans, conduct site visits, and issue approvals to ensure that electrical installations meet the requirements of the code. Electrical codes often reference standards developed by organizations such as the National Fire Protection Association and the Institute of Electrical and Electronics Engineers. These standards provide detailed technical requirements for electrical equipment and installations. Overcurrent protection is a critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity in the event of an overload or short circuit. These devices help to prevent overheating, fires, and equipment damage. Grounding is another important safety measure that helps to protect people from electrical shock. Grounding provides a low-resistance path for fault currents to flow back to the source, tripping the overcurrent protection device and energizing the circuit. Electrical equipment must be properly installed and maintained to ensure a safe operation. Improperly installed or maintained equipment can pose a significant electrical hazard. Regular inspections and maintenance can help to identify and correct potential problems before they lead to accidents. Electrical safety is a shared responsibility. Homeowners, contractors, and building inspectors all have a role to play in ensuring that electrical work is performed safely and in compliance with codes. By working together, we can create a safer electrical environment for everyone. Electrical codes and standards are essential for protecting people and property from electrical hazards. By understanding and complying with these codes, we can help to prevent electrical accidents and ensure the safe operation of electrical systems. Electrical safety is a complex and evolving field that requires ongoing education and training. Staying up to date on the latest codes and standards is essential for electrical professionals and anyone who works with electricity. In addition to codes and standards, there are many other resources available to help promote electrical safety. These resources include training programs, educational materials, and safety organizations. By taking advantage of these resources, we can improve our understanding of electrical safety and reduce the risk of electrical accidents. The Permit-by-Postcard program, while no longer widely used, offers valuable lessons about the importance of balancing efficiency and oversight in the permitting process. The program's focus on streamlining and random inspections highlights the need for continuous improvement and adaptation to meet the evolving needs of the construction industry. Electrical safety is a critical concern that requires ongoing attention and effort. By understanding and complying with electrical codes and standards, we can help to prevent electrical accidents and ensure the safe operation of electrical systems. Remember to always consult with a qualified electrician for any electrical work to ensure it is performed safely and in accordance with local codes. Electrical work can be dangerous and should only be performed by those with the proper training and experience. Always turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Electrical safety is everyone's responsibility. By following these simple precautions, we can help to prevent electrical accidents and ensure the safety of ourselves and others. The NEC, or National Electrical Code, is a widely adopted standard for safe electrical installations. It's updated every 3 years to reflect changes in technology and best practices. Understanding the NEC is crucial for electricians, inspectors, and anyone involved in electrical work. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for electrical systems to ensure safety and prevent hazards. Article 90. One of the NEC outlines the purpose of the code, which is the practical safeguarding of persons and property from hazards arising from the use of electricity. Chapter 1 of the NEC covers general requirements, including definitions, wiring design, and protection. It also addresses topics such as conductor sizing, overcurrent protection, and grounding. Chapter 2 of the NEC covers wiring and protection, including requirements for different wiring methods such as non-metallic sheath cable, metal conduit, and underground wiring. It also addresses overcurrent protection, grounding, and surge protection. Chapter 3 of the NEC covers wiring methods and materials, including requirements for different types of conductors, cables, and raceways. It also addresses the installation of these materials. Chapter 4 of the NEC covers equipment for general use, including requirements for receptacles, switches, lighting fixtures, and appliances. It also addresses the installation of this equipment. Chapter 5 of the NEC covers special occupancies, including requirements for hazardous locations, healthcare facilities, and agricultural buildings. It also addresses the installation of electrical systems in these occupancies. Chapter 6 of the NEC covers special equipment, including requirements for electric signs, swimming pools, and electric vehicles. It also addresses the installation of this equipment. Chapter 7 of the NEC covers special conditions, including requirements for emergency systems, standby power systems, and fire alarm systems. It also addresses the installation of these systems. Chapter 8 of the NEC covers communications systems, including requirements for telephone systems, data networks, and cable television systems. It also addresses the installation of these systems. Chapter 9 of the NEC contains tables and examples that are used to apply the code. These tables and examples provide guidance on conductor sizing, overcurrent protection, and other calculations. The NEC is a complex document, but it is essential for ensuring electrical safety. By understanding and complying with the NEC, electricians, inspectors, and others involved in electrical work can help to prevent electrical hazards and protect people and property. In addition to the NEC, there are other electrical codes and standards that may apply to specific installations. It is important to consult with local authorities and qualified professionals to determine which codes and standards are applicable to a particular project. Electrical safety is a shared responsibility. Homeowners, contractors, and building inspectors all have a role to play in ensuring that electrical work is performed safely and in compliance with codes. The NEC is constantly evolving to address new technologies and safety concerns. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations are safe and compliant. Electrical inspections are an important part of the permitting process. Inspections help to ensure that electrical work is performed in accordance with codes and standards. Building inspectors are trained to identify potential hazards and to ensure that electrical installations are safe. If an electrical inspection fails, the homeowner or contractor will be required to correct the deficiencies before the installation can be approved. Electrical permits are required for most electrical work. Permits help to ensure that electrical work is performed safely and in compliance with codes. The permitting process also provides an opportunity for building inspectors to review plans and to conduct site visits. It is important to obtain the necessary permits before starting any electrical work. Working without a permit can result in fines and delays. Electrical safety is a critical concern that requires ongoing attention and effort. By understanding and complying with electrical codes and standards, we can help to prevent electrical accidents and ensure the safe operation of electrical systems. Remember to always consult with a qualified electrician for any electrical work to ensure it is performed safely and in accordance with local codes. Electrical work can be dangerous and should only be performed by those with the proper training and experience. Always turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment. If you are unsure about any aspect of electrical work, consult with a qualified electrician.